again. That helps with my anxiety.
No, please. All right, so today is 11/2, and we're talking about scatter plots and correlation. Okay, and I'm going to tell you what those words mean in a second. All right, and so this will be our page 18. Although correlation, I will tell you, it's kind of right there in the word, correlation. Remember, a relation is just how something is related to something, and then co means together in the same. So they're related in the same thing. So when you're looking at your notes that I pre-printed you, we're just adding some stuff to it. Like most of the notes are already written. Put up your phone. Come on, y'all. Focus. So in general, there's...
Can you lights?
Yes, if you would like to, you can.
Yeah, so hey, play for lights. Sam, shut up.
Oh,
Give it a second to...
I'm scared of the dark. Doris, why are you here, boo?
Oh, it's so blue. Okay. Is that better?
Yeah.
All right. So, correlation... Hey. I need y'all to focus.
Sorry, I'm sorry. I need some caffeine.
All right. So scatter plots are just graphs that have only points. They don't have any like lines or curves on them. Like there's not any certain graph. It's just points. Okay, that's what a scatter plot is. All right. So discrete is what I was just saying. Discrete means just points. You don't have any lines or curves connecting anything. It's just points. All right. Now, you still have your x-axis and your y-axis, and so it's still showing how two things are related. When you look right here, see how this one's going up?
Yes.
Because it's going up, this is considered a positive correlation. This one, I don't mean if you connected one dot to another, because then, of course, it would be kind of going all over. I mean the overall pattern of the dots is going uphill. And in this one, the overall pattern is going downhill. So this one would be negative.
Can we keep the lights off, please?
For right now, we can.
Like, all through class period?
Maybe. That will depend on y'all.
What is that?
All right. This one here, though, if you notice, the dots aren't going up or down in any kind of pattern. They're just kind of everywhere. This one would have no correlation. Okay? So, hey. Do y'all have to move closer to me?
No, it's just he keeps laughing funny.
I'm going to need you to focus.
All right.
We're not doing a ton right now. I need you to chill.
It's up.
Sorry, Olivia. That's not even me, actually.
I need y'all to chill. Listen. Okay, so that was how you tell between positive. So this one's a positive because it's going uphill. So for a positive correlation, the overall pattern of points, not just like if you connected the dot, but the overall pattern goes up from left to right. So again, this isn't connect the dots. You're not going to try to like go. It says the overall pattern goes up from left to right.
On the strong correlation, or
no, it's on positive because we were talking about this one. This one's a positive.
what was it again? The
overall pattern goes up from left to right. This one is a negative correlation because they're going down. So under negative correlation, it's the same thing, but it goes down instead of up. So the overall pattern goes down from left to right.
goes
And
down.
yeah, always remember it's from left to right like we read. Okay, so positive goes up, negative goes down. And then this one is no correlation, and it's because the points are everywhere. There's no relationship between them. They're just completely random. Dots are everywhere. So there's no pattern at all.
Can we got an eraser line?
I don't have a pencil top one, but I have like one of the little... I can aim in the general vicinity, but I'm not a good thrower. Oh! Yeah, see, that didn't work out.
You made it to me if that roof wasn't there.
It was a Hail Mary.
All right, so...
No pattern at all?
Yeah, no pattern at all for no correlation. All right, so the strong and the weak, That is like how close, Sam, please don't sing. I'm literally trying to teach here. And you're supposed to be trying to learn here. But even if you're not interested in learning, other people might be, and this recording is also for our people gone. So you need to chill. You're about to sit right next to me. And be aware that you have chosen for me to be recording while I'm having to get on to you because you're not listening. That is not what I would have wanted to do, but you won't listen. So stop. Chill out, pay attention, and do what you're supposed to do. Do you understand what I'm saying?
Yes, ma'am.
Okay. A strong correlation is where the pattern is very close to being exactly what, like a line, if these would be lines, but they don't have to be linear. Okay? So like say the overall pattern was a bunch of dots looking like this, where it would look like a parabola, like our quadratic functions. It can still have a strong relationship. It might not be positive or negative because it would be both. But the strength of the correlation has to do with how close are the dots to being in a perfect row. Okay? So the strong correlation, it means the points are all close to the function that it's representing. And that could be linear. It usually is that we're talking about, but it could be other kinds of functions too. All right? The point, if for a weak correlation, the points aren't that close. They might still have a kind of a pattern, but they're not going to be that close to the function that it's trying to represent. And we're going to talk about specifically how you tell how strong or how weak it is in a minute. So linear associations occur when the points cluster along a straight line. So like here, if my pen was a thicker pen, I could make one straight line that kind of went through all the dots. It would have to be like thick like a marker.
I do is like those big Sharpies.
Yeah. Same with these. These are pretty close to being in a straight line. Like my pen is straight, right? And I can pretty much aim it to where I cover just about every dot. Do you see what I mean? All the dots are pretty much covered by my pen, which is straight, so this would be linear as well. Of course, if there's no correlation, you can't try to see if it's linear or not.
Yeah.
And then nonlinear, they might not go on a straight line, but they might go with some other pattern. So like you might have the quadratic.
So will this ever be like on a test?
Yes.
Yes, this will be on the next test.
Next test.
Yeah, we're on Unit 4.
When's the next test?
Oh, we're not there yet. I don't know the exact day, but because we just started Unit 4.
Do you think it'll be before Thanksgiving break?
Yes. So this is one example, or you have the kind that are like that, where they get bigger. You know, like they start out small and then they get, like those are some examples of nonlinear. But the points could still like cluster all around these patterns like this. You know, they might not be a straight line, but they could still be in a pattern. Okay? So outliers, this is another vocabulary word. They're the ones that, like, say everything is pretty close to being in a pattern, but there's one or two dots that, like, kind of throw the whole thing off. They're either going to be less or more, but, like, a lot. So, like, if you're looking at this picture, and I had all these dots that are here, but then I had one dot here, that would be an outlier. Okay?
So it wouldn't even be in the problem?
Well, it would just be like, okay, I'll use an example. Say we plotted all the ages of the people in this room. Okay? All of y'all's ages are going to be fairly close, but I'm a person in this room.
Yep.
My dot would be way away from y'all's. And there's a reason for why I'm an outlier, because I'm obviously not the student. But the point is, my data would skew y'all's. Y'all's data would all be clustered together, but mine wouldn't be. That's an outlier. And so there's lots of reasons why that can happen, but that's just an example of it.
Yeah.
So then we talk about lines of best fit, and of course line of best fit only works when it's linear. But, you know, there can be like other graphs that are the best fit too. So they want us to select which one is correct, okay? Which one is the correct line of best fit, okay? So
I'm going to take a wild guess. Alright, it's that one it's the third A.
Okay, so you want the points to be the closest to the line, right?
Oh, okay, I got you.
So if you look here, the points are kind of all over, right? They're not even, some of them are on the line, but there's more that are not. Here, they're not on the line, very many of them, but they're kind of close to it.
They're in the vicinity.
Yeah, and here they're even closer, right?
Yeah.
But here, the dots you can see are all on the line, or at least really close.
Yeah.
So this one's probably the line of best fit for A.
So the first A?
Uh-huh. For B, this one would be no correlation at all, so there's not even a line here. But if you look here, it's kind of like here. Oh, I see. They're doing it for each one. That makes more sense. Each column. I was thinking all the A's, all the B's. It's each column. So when you look here, which one of these lines is going closest to all the dots?
A and B. The first A and the first B.
Well, I just mean for just the first A and B. Which one's closer?
Oh, hold on. A. Because I can actually see a couple of dots that aren't even on the line on B.
Yeah. Okay, so A has a dot here, here, and here. They're off of it. B has here, 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 here. So this one's tricky. You're right, A has more on the line, doesn't it?
Yeah.
But these up here are not on the line, and they aren't here either. But now these two aren't. So the funny part is this one has less dots on the line, right? But it's actually the better fit because more dots are close to the line. So these are still close to the line, and these are now closer, whereas here we fit these, but these are all outliers. So when we move the line up to where it's in between them, it's closer to all of them, if that makes sense. It might be on less. Why are we listening to music, y'all? Turn it off. We're really not going to listen.
Wait, turn it down.
Oh,
You should not be listening to music right in the middle of lesson.
no, I'm just doing a soccer focus because when I'm just sitting here, I can't my DMC kicks in.
On this one, which one has the lines on this column? Which one has the lines closer to the most dots? Not necessarily.
Oh, then it's B. If you're talking about the dots that are closest to the line.
Well, like,
oh, wait, hold on. Yeah, it'd be, no.
all right,
Dots that
so,
are close to the line, like not on the line?
well, it doesn't matter if they're on it or not. You want the line to be closest to the most of them. So this one actually fits better because this one makes all of these over here further away.
Yeah.
So in this case, it would be this one. Which one of these fits better? A or B? B. B fits better. And then, of course, this one's a trick question because it asks which line is a better fit, and only one of them has a line. But doesn't that mean this one's the better fit because the line doesn't get close to any of them?
Yeah.
The reason it's this one is because there is no line that will fit this data. It's not a linear data. It's not even a relationship. These are just random dots everywhere. Okay? There's no relationship there.
Hey, is the first, slide your paper over to the right.
Okay.
Okay, I got it.
All right, the next part, let's look at the back. All right, so this part right here is how we tell how strong the relationship is. And I will show you once we actually start where you have to figure out the correlation coefficient instead of just using it. We'll show you how to put that in the calculator. But right now we're just starting with using it. You're not writing it yourself. So they use R for whatever the correlation coefficient is. You know how like we use M for slope? We use R for correlation coefficient. That's a big word, but it's just the number that assigns value to how strong the relationship is. It's always between -1 and 1. Okay? The closer it is to the 1 or the -1, the stronger it is. Like a relationship of a 1 or a -1 is a perfect relationship. That means every dot is exactly on that line. Okay? The closer it is to 0, because 0 is in between there, then the weaker the relationship is. If it was exactly 0, there'd be no relationship at all. That's like those ones that are just random dots. And the reason that it's negative and positive is because that has to do also with whether the dots are going down or up. So if it's a negative one, that's a line going this way. If it's a positive one, it's a line going this way. And if it's in the middle somewhere, it's a relationship, but the strength of it is determined by how close it gets to the 1. So like a 0.9 or a negative 0.9, those would be a pretty strong relationship. A 0.3 or a negative 0.3, those would be a pretty weak relationship because that's closer to the 0. All right? So they say what I was just telling you about the perfect relationship, okay? And 0 is no. So right here is how they break it down, okay? If it's in this range, of course we said a negative 1 was a perfect negative relationship. But if it's in between negative 1 and negative 0.8, it's a strong negative relationship. If it was positive, it's a strong positive. If it's between half and 0.8, it's moderate, meaning it's pretty good, but it's not strong. And then, of course, if it's less than half, it's a weak correlation. And being 0 would be no. I will say I've also seen it done this way. If it's between 0 and 0.33, it's considered weak. If it's between 0.34 and 0.66, it's considered moderate. And then if it's 0.67 to 1, and this could be negative or positive, it's strong. So this is another breakdown I've seen used in math. It's not that one's wrong and one's right. It's just a varied explanation. Either way, the closer you are to 0, the weaker. The closer you are to the 1s, the stronger. Okay? So, like, here's some examples of this. This would be perfect 1 because if I drew a straight line, I can touch every dot. It's perfect. Those dots are on that line.
Yeah, because the next one's a scatter, isn't it? And
yeah.
The rest of them are kind of scatters except for the negative 1 over there in the corner.
Yeah. This negative 1 is a perfect relationship too. It's just negative. That means I can draw a line and it touches every dot. Whereas these two are strong, but notice I couldn't draw one line that touched every dot. It could go in kind of in the middle of them.
Yeah.
And then here,
zigzag.
Yeah, these are pretty weak, but they are still, overall the pattern here still going up, and overall the pattern here still going down. But they're pretty weak. Like, there's not a giant relationship here. So you could kind of use it to make predictions, but it would be not really great.
Yeah.
And then, of course, this one, the dots are everywhere, so there's no relationship. I can't use this graph to predict anything.
Yeah.
Because any value down here can go with any value here.
Yeah.
Okay? So that's how the correlation coefficients are used. Like I said, I've seen this chart used more, where you have weak, moderate, and strong divided evenly, whereas here it's not really dividing it evenly. Like, they have half of it in the weak, and then they kind of split the upper half between moderate and high. It's not a right or wrong. Those are both right. They're just used differently. That's all. Okay? So we're going to have a a correlation scatter plot quiz. Okay? So I'm about to put it in Google Classroom. So it's kind of like you did yesterday. It's a Google quiz.
Is this all we gotta do today?
This goes in your journal.
When we get